Let's read this problem right here. It says, for each of the following indefinite integrals, identify u and dx, then rewrite the integral in terms of u and du, but do not integrate. So we're not actually going to integrate. So essentially all we're doing is steps 1 through 4. So let's do step 1 again. It would be identify u. So we would let u equal the inside, which is x squared plus 1 in this case. Step 2 again is find the derivative of both sides. So on the left we would have du dx would equal, well, the derivative of x squared plus 1 is 2x. Step 3 is solve for dx. So if we solve for dx, what we would do is we would multiply both sides by dx and divide both sides by 2x. Again, it's that cross multiplication idea. So it would be du over 2x. Sorry, let me just write it out instead of saying it. Dx would be du over 2x. And then step 4 would be rewrite the integral in terms of dx and u. So remember, we have to substitute in for dx and we have to substitute in for u. So when we do that, we would have the integral of, give me a second. We would have the integral of, well, it would be 2x, and then here instead of x squared plus 1, that's u raised to the 4th. And then instead of dx, that's du over 2x. And then if you notice, the 2x's simplify, and we're left with the integral of u to the 4th du. And that's all they want on this problem, is you to set it up so you could integrate it. I just want you to get used to your u substitution problems, okay? This would be super easy to finish this problem because the integral of u to the 4th would be u to the 5th over 5 plus c, and then you back substitute for u. So that the integration becomes easy once you have these 4 steps done. Let's go ahead and try the next one. It says the integral of 3x squared times the square root of x cubed plus 1. This looks like a product. There is no official product rule in calculus. There's something that's kind of the opposite of the product rule, but we're not going to learn it this semester. So this semester, all we have to do is u substitution. So let's do this again. Step 1, let's identify u. So let's let u equal, now it's the inside, it's the higher power one. So in this case, it's x cubed plus 1. Step 2 is find the derivative of both sides. So du dx, the derivative with respect to x of both sides. The derivative of x cubed is 3x squared. Again, step 3 is solve for dx. So dx would equal, well, we're just going to multiply both sides by dx, divide both sides by 3x squared. So that would give us du over 3x squared. Step 4 is we need to substitute that back in. Instead of dx, we're going to write du over 3x squared. And instead of x cubed plus 1, we're going to write u. So let's rewrite this integral. This will be the integral of, well, the 3x squared stays the same. Instead of the square root of x cubed plus 1, I'm just going to write it as u, but I'm going to raise it as u to the 1/2 because that's how we would integrate it using the power rule, right? And then instead of dx, I'm going to have du over 3x squared. Again, notice what happens. My 3x squared simplify here, and I'm left with the integral of u to the 1/2 du. Super easy to go from there. You would just integrate. You would have u to the 3/2 over 3/2, which is 2/3 u to the 3/2. Back substitute for u and you'd be done. But that's not what this problem asked to do. This problem asked for you to just set it up in terms of u. Okay? Let's keep on going. How about part C here? Part C says the secant squared of x and tangent x plus 3. So this one's not quite as clear as what's quote-unquote the inside, but let's think about it. We have 2 real choices, secant squared or tangent. And the question is which one is the derivative of the other? And what I know is the derivative of tangent is secant squared. So I'm going to let u be the tangent, okay? So let's let u equal tangent of x plus 3. U is going to be the tangent of x plus 3. So step 2, when we do that, we're going to have du dx. Well, the derivative of tangent of x plus 3 would be secant squared of x. And so step 3, when we solve for dx, again, you're just essentially cross-multiplying. Multiply both sides by dx, divide both sides by secant squared of x. You would have dx equals du over secant squared of x. So now we're going to do our substitutions. We're going to substitute in for dx. We're also going to substitute in for u. And we're going to rewrite our integral. So that's step 4 is rewriting that integral. So this would be the integral of, well, secant squared of x wasn't anything, so let's just write secant squared of x. And then we have, instead of tangent x plus 3, that's what u was. And then instead of dx, we have du over secant squared of x. Notice what happens. The secant squared of x is simplify, and you're left with the integral of u du. Again, that would be super easy to integrate. It would be u squared over 2 plus c and back substitute for u. But again, that is not what this problem asked for. It just wanted us to set it up. So a couple of you might have gone the wrong route on this problem. So I just want to discuss how would you know if you actually went the wrong route. Well, let's actually take a look at it and see on this one. So what would you do if you said let u equals secant squared of x? Well, if you did that, and you maybe if it helps you, you see it as the secant of x squared. So if you wanted to find du dx, you'd actually have to use the chain rule, which would be 2 secant of x, and then you'd have to multiply it to the first power, right? Then you'd have to multiply that times secant x tangent x. And so this would be 2 secant squared of x tangent of x. And you would go in and you would start, and that's what du dx would be. So then you'd have dx would be du over all of that, the 2 secant squared x tangent x. And if you went back in to write your integral, you'd have the integral of, instead of secant squared of x, that would be u. And then instead of tangent, or no, then you would still have tangent x plus 3. And then instead of dx, you'd have du over 2 secant squared of x tangent x. And what you'd notice is that nothing simplifies. And you still have an integral that has x's and u's, and it just doesn't work properly. You might have thought that instead of secant squared x, it was just secant x, but you would still end up with a secant x tangent x. You'd still have a lot of work to do, and it just wouldn't work out. So how do you know when you do u substitutions wrong is when you've placed u in, or when you've substituted in for u and du, you're still going to have functions that have x's in them. And when you have those functions with x's in them and you can't get rid of them, you can't do the integral. You need everything in terms of one variable if you want to do the integral. So all of this is effectively junk. You're not going to be able to do any of that, and you'd have to start over by choosing a different u. So practicing choosing u is very, very important, because it could send you down a rabbit hole that takes a long time, and it's not the right way of doing it. So let's look at d here now. D says the integral of x times x squared plus 1 raised to the 4th. This one's not as easy as the other ones, because you certainly wouldn't want to FOIL this one out. It would take far too long. So let's start off with step 1 being let u equal whatever the inside is, that higher power function. In this case, again, it's x squared plus 1. Again, step 2 is find the derivative of both sides. So we'd have du dx would equal to, well, the derivative of x squared plus 1 is 2x. We've done that numerous times already. Step 3 again is solve for that dx, and if we solve for dx by doing our cross multiplication, we'd end up with du over 2x. And then what we want to do is substitute in for dx and also substitute in for u. When we do that, we would end up with the integral of x times, instead of x squared plus 1 to the 4th, that would now be u to the 4th. And then instead of dx, we would have du over 2x. Again, our x's would simplify here. We'd have a 2 in the denominator, which is a constant multiple. It's actually a constant multiple of 1/2. So this is 1/2 times the integral of u to the 4th du. Again, that would be super easy to integrate. It would be u to the 5th over 5 times 1/2 plus c, and you back substitute for u. But let's just go ahead and do what the problem wanted, which was just substituted in terms of u's. Okay, let's move on to e. E is x squared times the square root of x cubed plus 1 dx. So what do? First step, we let u equal the higher power of the inside, which in this case is x cubed plus 1. Step 2 is we find the derivative of both sides. So this would be du dx equals, well, the derivative of x cubed plus 1 is 3x squared. Step 3 is solve for dx. So dx would equal du over 3x squared. Again, we've already seen several of these problems. So what do we have here? Step 4, we rewrite the integral in terms of u and dx's. And so I'm going to replace dx with du over 3x squared. And I'm going to replace x cubed plus 1 with u. When I do that, I look at the integral, and I would have the integral of x squared, and then it would be the square root of u, which I'm going to write as u to the 1/2. And then instead of dx, again, it would be du over 3x squared. When we do that, we know that our x squareds would simplify. The 3 did not simplify, so that's perfectly fine. That's just a constant multiple of 1/3, so we pull that out in front. Make sure you're not pulling out the number 3, you're pulling out 1/3, and this is u to the 1/2 du. So what happens now? Well, this is all the problem wanted, but we could finish this problem if we wanted. Let me write the answer down real quick. If we wanted to finish this problem, we'd have to integrate u to the 1/2. Well, again, that would be u to the 3/2 over 3/2, which is 2/3 u to the 3/2. Then we'd multiply that times 1/3, and then of course we'd do our plus c. But then you'd back substitute for u, and you'd have your answer. Okay, so let's look at f here. I can see just by looking at it, there is a typo for sure. This right here shouldn't say secant squared of dx. That should say secant squared of x right there. And if you look, the only difference between f and c is the constant multiple, and that's what you should have noticed in parts D and E as well, is they're all similar to A, B, and C. The only thing they're off by is this constant multiple. So the idea with f is, what's the different constant multiple? Well, the idea is there's this 2 out in front, right? And so what we could do is say this is 2 times the integral of secant squared of x times the tangent of x plus 3 dx. And then here we're just going to say c part c, which is the part straight above. And when you look at part c, we already did all the substitution, so we already did all of that work. So the only difference is this is going to be 2, sorry, let me use black. It's going to be 2 times the answer that we got in c. So in this case, it's 2 times the integral of u du when you make those substitutions. Okay, so again, you had parts A, B, and C, which all, when you use that u substitution, they all came out perfectly where it canceled out and it was only u's and du's. And then you had D, E, and F, which is the exact same problems, just off by a constant multiple. And it's perfectly fine if you're off by a constant multiple. Just pull that constant multiple out in front and you'll be able to do your u substitutions like you said. So let's go ahead and move on to some u substitution problems on the next page.